Hi everyone, and welcome to following of the bonding curve.sol. And so in the previous part we focused on the mappings and the constructor and the first function of this smart contract. We also explained what bonding curve is in setting the price of the ERC20 tokens. So now we're going to continue with the rest of the functions. So function, and here we're going to write the sell tokens function. So sell tokens, and this will get the token amount. So this function will get the, so in the previous one we didn't get any variable, and the message.value would determine the amount of ether that we want to spend in order to buy the tokens, and automatically the number of tokens, the maximum number of tokens that the person would get would be calculated. So here we'll calculate the token amount, which we haven't written the function yet, but this function will determine that for us, and then we would mint the tokens and increase the balance of the buyer, and then also determine the spent amount and add this to the supply, so that later the price will increase accordingly. So this gets current price will be affected by this supply. So now we will have this function that gets the uint 256 token amount, and so the token amount and this is a public payable, because here we're going to pay to the address who wants to sell the tokens. This function is payable. And now let's open the brackets. So first of all, we can set the ETH amount and then check whether the balances of the message.sender is enough. So we'll have uint 256 ETH amount, and again we'll have another calculate function that calculates the ETH amount, calculate ETH amount, so ETH amount, and then it will get the token amount. Once we do that, we need to set the requirement that the balance of the message sender be greater than equal than the token amount. So if you, for example, you want to sell 5 tokens, you need to at least have 5 tokens. This is why we write the requirement. So balances of the message.sender be greater than or equal to the token amount, otherwise insufficient balance. So afterward, after this requirement, we'll burn the tokens. So the person wants to sell it, so this is equal to burning the tokens. So burn payable message sender. So payable here might not be necessarily important here, but I've written it, and also it will get the token amount. Here we go. And then we'll have the payable, but here it's important to write the payable msg.sender, because we're going to transfer some ETH to the address of the person who wants to sell the tokens. So transfer and the ETH amount. Here we go. So the next function is calculate token amount, which we've used here. So the input of it is the ETH amount and the output will be the token amount. So now there's also something here that we need to consider, and that is the supply. So once you sell the token, you should decrease the supply so that it also influences the price. So here the supply will be minus equal to the spent amount, and the spent amount here is the token amount. So or actually the ETH amount, right? Yes, it's the ETH amount, because the ETH amount determines the price, and the price is in the units of ether. So ETH amount, and here we go. Okay, and the next function here is calculate the token amount. Calculate token amount. And then it will get uint 256 ETH amount, uint 256 ETH amount, public view returns uint 256, public view returns uint 256. So let's open brackets, and here we'll have uint 256 price per token, uint 256 price per token, so this is going to be equal to get current price function, which we'll write in the future. Get current price so this is the price per token right now, and so the token amount will be written this way: uint 256 token amount equals the ETH amount divided by the price per token. Price per token. Here we go, and then we'll return the token amount. Return the token amount, and here we go. So now the next function is the calculate the ETH amount, which we have used in the previous functions. Calculate ETH amount. So it will get the token amount as an input, uint 256 token amount, and it's a public view returns uint 256, public view returns uint 256. So for this function, uint 256 price per token again, uint 256 price per token, which equals to the get current price function, and here we go. And now we're going to determine the ETH amount, uint 256 ETH amount, which equals to the A multiplied by actually token amount multiplied by price per token. So that's it, and we'll return the ETH amount as a result. So now let's write the final function here. So function, and this is the get current price, which is the most important one, and it will determine everything. So public view returns u into 256, public view returns the u int 256, and right over here we'll have the u int 256 price, u int 256 price, and this follows the formula that we wrote earlier. So a multiplied by the cumulative purchase amount or the supply. So here we'll have the supply. So let's take a look at above, and here we can, this is not, a is just a coefficient of the x parameter and b is a fixed amount, so we can set this linear or non-linear. So if you want to set it linear, a multiplied by the supply plus b, or if you want to set it the parabolic amount, you can set it to supply again. So let's try the parabolic instead of the linear, and can change this later. So that's it. So now we will have the u int 256 price like this, and it will return the price, return price. So now in the end we'll have the fallback and receive functions, because we want to fund the contracts in order for the seller to be paid with the Ethereum. So here I will write the receive external, receive parentheses external, and also payable. So open and close the brackets, also fallback, parentheses, external payable, open and close the brackets like this, and here we go. So that's it for this smart contract. We'll compile it in the next part. So if there are any errors, don't worry, we'll compile it in the next part and also deploy it afterward, so that we test all the functionalities of this smart contract.